So we're going to finish up our packet today, and we're going to talk about complex numbers in their true complex form. So consider the number 5 plus 2i. Since there is an I involved, this is an imaginary number, and they're called complex numbers when you have an addition or a subtraction, or even without it, it doesn't matter. They're still considered complex numbers. So because 5 is the real number and 2i is called the imaginary number, they are not like terms and they cannot be combined. So basically, this type of expression is called a complex number. So complex numbers are always in the form of a plus bi. Okay, this is the real part, such as the 5. And this is the imaginary part, such as the 2i. So 5 would be A and 2 would be B. Not 2i, but just the number in front of the I value would be the B value. So in the next couple of examples, we're simply going to add and subtract complex numbers. And it is just like combining like terms. So what you want to do, if you notice in number 1, we have an a plus bi plus an a plus bi. So what we're going to do is we're going to grab our a values. This is what you should be thinking. You don't necessarily have to write it down, but this is what you should be thinking. I'm going to add my a values together because of that plus sign. And then I'm going to add my b values together. I apologize, it's not a -3. So I'm going to add my b values together. That's -2, and that's positive 5i. If this had been negative 5i, then we would write down -2 minus 5i. But it is just like combining like terms. So if you don't have to write it down, I'm a visual person. I like to see it. And so if you can do that without, add up your A's, add up your BI's, and then put those two results together. So in the next example, what you should be thinking is 4 plus 7, add up your A's, and then I should be thinking I plus -5i, because notice that is a -5. So I get 11 out of the first one. When I add these two together, I actually get -4i. So you're not going to write it down as plus 4i. You're just going to write it down as -4i. And that would be your final answer for number 2. Now, subtraction is tricky, so you have to be very, very, very careful with subtraction. Same thing. This time I'm going to do 7 minus 2. And I'm going to do -2i minus 6i. When you are subtracting, always watch for double negatives. Now, we don't have them in this example, but we will have them in the next example. So this is 5. When I combine like terms here, I get -8i. That would be my final answer for number 3. So you are combining like terms by either adding or subtracting the a values from each other and the b values, the bi values from each other. Now, in example number 4, you have 3 numbers. You have 6i, 3 complex numbers. You have the 6i, you have the 14 minus I, and the 5 minus 3i. So what we're going to do is we're going to add 3 numbers or subtract. This one does not have an a value, so that would be 0 minus 14 plus 5, minus 14 plus 5. So you have to keep it in order. So that ends up being -9. Then I'm going to take my imaginary units, the BI's. So the first BI that I see is 6i minus -i. There's a set of double negatives that we will turn to positive. So minus -i and then plus -3i. So these two turn to positive. So that is 7i minus 3i which is positive 4i. And that would be your final answer for number 4. So adding and subtracting, even if there are multiple complex numbers in the problem, you still follow the order of operations. So we subtracted 14, we added the 5 in the first one, and then notice that I put a 0 out here. Even though this first term did not have an a value, technically that's 0 plus 6i. So there is an a value, it's just the a value equals to 0. So make sure you fill in all those gaps and make sure that you have an a plus bi value before you start that. Now, when it comes to multiplying complex numbers, please remember that an I times an I becomes an I square, and an I square is always equal to -1. So when you multiply, exponents change. When you add and subtract, exponents don't change. The coefficients, those front numbers in front of the variables change, but exponents don't. When you multiply, both of those things happen. The front numbers change and the exponents change. So what we're going to do is we're going to distribute and FOIL with imaginary units. You do this just the same way you do if that were 2x minus or times 8 minus 3x. You're going to do it the same way. So we're going to distribute 2i times 8 is 16i. Then I'm going to multiply the 2i times the -3i. That gives me -6i square, because an I times an I is an I square. Okay, so what I did is I did 2i times 8 and then 2i times 3i. So that's where I got this from. Now, every I square becomes a -1. So that's -6 times -1, and that would turn into +6 plus 16i. Now, the reason I wrote it this way is because this statement right here in your directions say all final answers must be written in A plus BI format. So the A value comes first, and then your imaginary term comes last. So here I'm going to multiply -i times -2, which gives me +2i. -i times +10i is -10i squared. Now, every I square becomes a -1. So that's -10 times -1, which would turn into +10 plus 2i. And that would be your final answer. You cannot leave an I square in an answer. You can't leave anything bigger than just an I to the first power. Is it okay that it's 16i? Yes. Is it okay that it's 2i? Yes. The front number doesn't matter. What matters is that your exponent cannot be bigger than 1, so you're going to have to simplify that, and we did that in a previous lesson. So in number 7, we are actually going to to FOIL. So we're going to multiply 4 times 7. That gives me 28. 7 times -i gives me -7i. So I'm going to erase that so we can distribute the I. So I times 4 is +4i. And this is where you need to be careful. I times -i is -i squared. Most people forget that I square on the last part of the FOILing process. Just remember, an I times an I becomes an I square. So what I can do is I can add these two numbers together because they are like. That gives me -3i. Then I have to take the I square out and replace it with -1. Double negatives become plus positive, and then I can add 28 and 1 and get 29 and bring along the -3i. That would be my final answer for number 7. In number 8, we're going to do the same thing. We're going to distribute So 2 times -5 is -10. 2 times -6 or -3i is -6i. Then I'm going to do the middle part. -4 times -5 is positive 20i. And -4i times -3i is positive 12i squared. Be very careful. An I times an I becomes an I squared. So once we get here, I can add these two together, and that gives me 14i. -6 plus 20 is positive 14. Here, I'm going to have to turn that I square into a negative. So that produces -22, because that turns into a -12. -10 and -12 become -22 plus 14i. That would be my final answer for number 8. Now, in the last two problems on this particular page, 6 minus 2i squared is the same thing as saying 6 minus 2i times 6 minus 2i. So we're going to FOIL. We get 36 first, 6 times 6. 6 times -2i is -12i. Then I'm going to go through and I get a -12i, another one, and then a positive 4i squared when I multiply -2i times -2i. So in the middle, I get -24i. When I add those together, this is going to become positive 4 times -1, which is -4. And when you add 36 and -4, you get 32. 36 and -4 gives you 32 minus 24i. All right. Now, in number 10, they are incorporating both things. We're going to FOIL and then we're going to subtract. So the first thing that we need to do, and I'm going to erase this up here just so I can have plenty of room to write this down. All right, so I am actually going to write the steps above the problem so you can kind of follow along with that. So I'm going to FOIL first. 1 times 9 is 9. 1 times 3i is 3i. 7i times 9 is 63i. And 7i times 3i. 7i times 3i is positive 21i squared. Be careful with the last terms. So I can add these two together. So I get 9 plus 66i. That I squared becomes a -1. So the last term becomes -21. This becomes a -21. 9 minus 21 is -12 plus 66i. 9 and -21 add up to -12. Now, that takes care of this part. Now I need to subtract 4 plus 2i from that answer. So I should be thinking, and clear some space over here so I can show you my thoughts. I should be thinking -12 minus 4. Those are my A's. That gives me -16. And I should be thinking 66i minus 2i, which would give me 64i. And that would be my final answer once I did the FOILing and then I added the two outcomes together. All right. Now, complex conjugates, when you multiply these together, they are always real numbers. And what makes them a complex conjugate is it's the same factor. The only difference is one is a plus and one is a minus. So if you notice in number 11, I have 8 plus I and I have 8 minus I. What happens when you multiply complex conjugates together, the O and I of the FOIL process will cancel. So watch what happens when I completely FOIL this problem. So 8 times 8 is 64. 8 times negative I is negative 8I. Then I move to the inside. That gives me positive 8I. And then an I times a negative I becomes a negative I square. Now, normally, in all the previous examples, we would add those together. But negative 8 plus 8 is 0, so it drops out. So that leaves me with 64 minus negative 1, because every I square becomes a negative 1. So 64 plus 1 is 65. When you multiply complex conjugates together, you get just a number. The imaginary units go away. So same thing here. I have conjugates because I have a 5 minus 4i, and I have a 5 plus 4i. So when I FOIL, I get 25, and then I get plus 20i. Then I get a negative 20i, which will cancel with that positive, and then I get a negative 16i square. So when I go to add these two together, since they are opposites, they cancel. That leaves me with 25 minus 16 times negative 1. The negative 1 comes from every I square turning into a negative 1. So that gives me 25 plus 16, which is 41. And that's a real number. Now, when you multiply complex conjugates together, they can be any real number, positive, negative, decimal fraction, 0. So the last thing that we're going to do in this particular section is we are going to divide complex numbers. The first 4 problems that you see on your screen right now all have monomial denominators. So if you have a monomial denominator, this rule right here, you multiply the top and the bottom by I, and then you get rid of any I squares. What you cannot do is you cannot have I in the denominator of a fraction. You cannot have I in your denominator. So if I take this fraction and I multiply the top by I and the bottom by I, that gives me 10I on top of 2I squared. Well, as we've seen in some of the previous examples, every I square turns into a negative 1. So that eliminates the I in the denominator. So multiplying the top and the bottom by just I eliminates the I in the denominator. You cannot have I in the denominator of a fraction. Now, the last thing we can do is we can look at the number. 10 divided by negative 2 reduces to negative 5. So this answer would reduce to negative 5i. In number 14, since I have a monomial denominator, a one-term denominator, I am going to multiply the top and the bottom by I. So across the top, I get 4i. Across the bottom, I get negative 9i squared. That becomes 4i divided by negative 9 times negative 1, because every I squared turns into a negative 1. So that gives me 4i over positive 9. Since I cannot reduce 4 and 9, I leave it as 4i over 9, or you can write it as 4 over 9 with the I behind the fraction. Same exact thing, okay? So if you type in Math Excel this way and it says, not quite in the right format, just drop the I to the back of the fraction, 4 over 9, and it should accept it. So for number 15 and 16, we're going to do the same thing. We have a little more work to do on the top because we have to multiply that I times 2 terms. So we're going to have to distribute across the top. So I times 28 is 28i, and I times negative 8i is negative 8i squared. So be very careful. Across the bottom, I get 4i squared. Now, this turns to -1, so I end up with 8 plus 28i over -4. Both of those I squares turn to -1, so -8 times -1 is +8, and 4 times -1 turns into -4. Now, I am going to have to separate that so that I can get it into A plus BI format, which is what my directions said. So I'm going to take 8 and divide it by -4. If it reduces or divides out, that's great. And then I'm going to take 28i and also divide that by -4. Now, when I do that, 8 divided by -4 becomes -2, and 28 divided by -4 becomes -7. Bring along the I. So that would be my final answer in A plus BI format. Now, the last problem with monomial denominator, we're going to multiply the top and the bottom by I. So we're going to distribute across the top just like we did in number 15. So I times -8 is -8i, and I times -2i is -2i squared, all over 6i squared. So what happens here is we get -8i minus 2 times -1 over 6 times -1. So I wrote it out a little bit more this time so that you can see where the I squares are going, because can't have an I square. So this becomes 2 minus 8i over -6. So I'm going to separate that. I'm going to have to go into number 18 space a little bit. 2 over -6 minus 8i over -6. This becomes -1/3. This becomes positive 4/3 I. 8 over 6 reduces to 4/3. Now, I know we don't like fractional answers, but that's what we get when we deal with division problems. So please keep that in mind. All right, if you have any questions, make sure you ask. And then the last 4 problems, they are binomial denominators. So if we go back up to our rules list, it says if the denominator is a binomial, you multiply the top and bottom by the conjugate of the denominator. Okay, so you're going to multiply the top and the bottom by the conjugate of the denominator. The reason we do the conjugate of the denominator is because you cannot have an I in the denominator. And when you multiply by conjugates, you get just a number. So in order to get the I out of the denominator, when you have a binomial denominator, a two-term denominator, you have no choice but to multiply by the conjugate. So the conjugate of 5 minus I is 5 plus I. Okay, so I'm going to distribute on the top, and I will FOIL the bottom. And remember, when you multiply conjugates and you FOIL, the O and the I should cancel. So as I distribute across the top, -2 times 5 is -10. -2 times I is -2i. When I FOIL across the bottom, 5 times 5 is 25. 5 times I is positive 5i. Then I get -5i, and see how those two terms are going to cancel. And then the last one, -I times positive I is -I squared. So when I go to collect like terms here, those cancel. In the denominator only, I get 25 minus -1, because every I square becomes a -1, and this minus has to stay. So that's actually 25 plus 1. So I end up with -10 minus 2i over 26. Then I have to separate that answer. So -10 over 26 minus 2i over 26. Both fractions reduce by 2. So my final answer for number 17 would be negative 5 over 13 minus 1 over 13i. Drop that I to the back, and that would be your final answer for number 17. So the binomial denominators require a lot more work than the monomial denominators do. So for number 18, we're going to multiply the top and the bottom by the conjugate of 6 plus 2i, and the conjugate of 6 plus 2i is 6 minus 2i. So we will distribute across the top, and you will always shortcut FOIL the bottom if you are multiplying by conjugates. So I'm going to erase this because obviously I need more space than I have provided myself. So when I distribute across the top, 5i times 6 becomes negative 30i. 5i times negative 2i is negative 10i squared. So we have an I squared we're going to have to deal with. Across the bottom, 6 times 6 is 36. 6 times negative 2i is negative 12i. 2i times 6 is positive 12i. And 2i times negative 2i. 2i times negative 2i is negative 4i squared. Here again, do not forget the I squared on that term. Now, across the top, that becomes a negative 1. So I get positive 10, negative 10 times negative 1, plus 30i. When I combine these two together, they cancel. I get negative 4 times negative 1, which becomes positive 4, and 36 plus 4 becomes 40. So when I separated 10 over 40 plus 30 over 40i, that reduces to 1/4 plus 3/4 I. Final answer for number 18. So in the last two examples, we're going to do the same exact thing. So I'm going to multiply by the conjugate, which is 2 minus I over 2 minus I, the conjugate of the denominator. This time, I have to completely FOIL the top, but I can still shortcut FOIL the bottom because the O and the I should cancel because we're multiplying conjugates together. So when I completely FOIL the top, I get 14 minus 7i, and then I get 6i plus 6i, and minus 3i squared. Now, I'm going to keep going with the top. I can add these two together, so that gives me 14 minus 1i. This becomes a negative 1, so that becomes plus 3. So I end up with 17 minus I as my numerator. My denominator. When I multiply across the denominator, I have 2 times 2, which is 4. 2 times negative I, which is negative 2i. 2 times I, which is positive 2i, and those will cancel. And then I times negative I becomes negative I squared. So these two terms, add them together, they cancel. This last term becomes negative 1, so plus 1. So 4 plus 1 gives me a denominator of 5. When I split that, I get 17 over 5 minus 1 over 5i. There's an understood 1 right there, so your numerator would stay 1. You can't reduce 17 over 5, so we're just going to leave it at 17 over 5. The last one works the same exact way. We're going to multiply by the conjugate of the denominator, which would be 4 plus 2i. I'm sorry, it would not. I read my numbers completely backwards. It would be 2 plus 4i. So we're going to completely FOIL the top. When we FOIL the bottom, the O and the I should cancel. I apologize for the dog barking in the background. I have no idea what's got him all stirred up. I really apologize. So when I foil across the top, 1 times 2 gives me 2. 1 times 4i gives me 4i. 8 times 2 gives me 8i times 2 gives me 16i. And 8 times 4, that gives me 32i squared. So I'm going to keep going with the top. When I add these two together, that gives me 20i. This becomes a negative 1. So I end up with 2. Actually, this becomes negative 32. So I end up with, when I combine, I apologize, this becomes a negative 32. So 2 minus 32 is negative 30 plus 20i. That's my numerator. Now I'm going to work on my denominator. So 2 times 2 is 4. 2 times 4i is 8i. Negative 4i times 2 is negative 8i. And you see how those are opposites, so they'll cancel. Negative 4i times positive 4i is negative 16i squared. So when I add these two together, they cancel. I get negative 16 times negative 1 because every I squared becomes a negative 1. And that gives me 16. 4 plus 16 becomes 20. So my denominator turns into one number with no imaginary unit in it. So I'm going to separate that, negative 30 over 20 plus 20 over 20i. And that gives me negative 3 over 2. And here I get just plus 1i. And that would be my final answer for number 20. So if you have any questions about adding, subtracting, distributing, foiling, and then using conjugates to get rid of denominators, please make sure that you are asking those questions.